Hello, everybody. So, welcome back for week 5 of our course. So, we're past the halfway. I guess the week 4 homework is due this evening, but yesterday marked the exact halfway point in the course. So, downhill slope from now, and got a few things to go over. The reading material is a lot lighter this week, if anybody's looking at that. It's just the stuff I'm saving and loading file, saving and loading data. So we'll look at that at some point this week. I'm gonna start off with this, just a little spiel I like to give, and just about every class I teach. So teach IT, so we're going to be sitting at computers, and sitting at desks working on a computer is sort of a terrible thing to do to the human body. So I like to talk a little bit about ergonomics every class, just to do a quick bit on that. Then we'll look at 3D modeling stuff, in particular, a little bit about materials, and I guess we'll start into some key points of shaders today. We go over some of the things about materials, and Wednesday we'll get into shaders. Yeah, color is not enough for 3D model. We have to define how the light reflects off of it, and all the behavior, light and shadows and all of that. So we set up materials to just a simple color like we do in 2D, as well as a light source. We have to have all of that information. And shaders are when we code it, usually so that we're doing something dynamic with it, because it's a lot of work to write all the code that we could just go through and click checkboxes for. So usually materials we'll just do from the, if it's non-dynamic, we just kind of go through and set a material. But if we're going to change it, then we can do a shader, but we can also code it up entirely. And there's a standard form of interface for those that shaders use for visual scripting interface, which we're using Godot, so we haven't seen the visual scripting much, but with game development, this industry standard is to use visual scripting tools. We'll see a little bit of that today when we look at the visual shaders. Godot doesn't have one right now because the old one was the one that was from somewhere in version 1, 1 point something, up until 3.5 last version. Most it was done together quickly years ago, and there's been a lot of improvements on that stuff over the years. And somebody created a new one, but the new one was not going to be backward compatible. So what they did is they just removed visual scripting from Godot 4, and then they'll bring back in the new one in Godot 5, and then hopefully that way backward compatibility won't be an issue, because most people aren't going to try to need to work with a 10-year-old game at that point. But in Unreal, the blueprint, in Unity, it was called Gold. I think that's the name to just visual scripting at some point. Visual Scripter. There's something, a low code solution is what they're called. So we have graphics that we can make nodes, so little squares, we'll see in a moment. Different nodes that represent variables and parameters and functions that are built into our objects, the same ones we ask for in our script, right? Just instead of typing the name and a text file, we have a little visual representation of that, and we connect them together. And it's really nice when debugging, because you can see the data flow through and you actually get a visual representation. And those things go through the same compiler as what the text file does. So at runtime, we end up the same thing as going through the machine. It's just we have a low code solution for it, where we're dragging our mouse around using nicer graphics than a text editor. After talking about materials, we're gonna look at some generative things. So landscape and trees. We'll start with those. And Blender will have in Blender we can just generate a huge landscape. A parameterized landscape, so we adjust parameters to customize it. And same thing, parameterized trees, we just generate a whole tree shape instead of going through and moving every vertex like we've seen. A couple plugins there that are nice. So we use that and we look at multi-mesh instances. So we can take one tree and turn it into like an entire forest. Fill up the entire landscape with copies of that one tree. So it's still very memory efficient because we only have one model loaded in. If we try to make individual models for every tree in the forest, that's going to fill up RAM on most computers very, very quickly. Start to slow things down. So multi-mesh instances are just more difficult than that. And the thing we're going to make with that, the landscape and then the little forest around it, we will use on Wednesday when we look at shaders. And then again in week 7 when we look at VR stuff. Because last year we ran out of time for VR stuff, so I was just going to work pieces in along the way. And that way we're ready to just throw it together there at the end. First off, little spiel I like to give about ergonomics is sitting on the computer is sort of a terrible thing to do to human body. One of my first examples, there we go. I'll turn this a little. So this old type of keyboard, regular keyboard, it's flat. But notice that when my hand's relaxed, actually there's the relaxed position of my hand. It does not match up with the shape of the keyboard. That's sort of a big one. And that over time, just forcing our hand into a different position and adjusting our fingers, it's unnatural. If you pay attention to it, you can feel your muscles pulling in strange ways here. That's one of the big things that eventually develops carpal tunnel syndrome. The carpal tunnel is just a tube that runs up your arm, from your hand, up your arm to your spine, and it holds all of the nerves that control your hand, or all of the nerves that connect your hand to your brain go through this little tube. And when that tube gets damaged, my understanding of it is that your brain just always receives a pain signal from your hand. Your hand just constantly tells your brain that it hurts no matter what's going on. Kind of, hurt is very, very annoying. Doesn't count as a disability, so if that happens, then you just kind of have to keep working with your hands constantly hurting, or your brain thinking that your hands are constantly hurting. Mouse is really bad as well. The traditional shape of mouse can't even hold that in the usable shape. So that's where we get into ergonomic stuff. I have some examples here. If people want to use them next time you're on campus. So here's an ergonomic keyboard. You can see the shape, the way it kind of bends up, and the keys aren't all perfectly square in a grid. They're shaped differently to fit with our fingers. I guess you can kind of see the curve there. And when I set my hand here, right here's the relaxed position of my hand, you can see that curve of that keyboard perfectly lines up with the relaxed position of a hand. So I'm not constantly using keyboards like this, I'm not constantly putting strain on that, on the tube that holds all the nerves for your hand. There are other good shapes. So for like a model, They ever used a vertical mouse before? So the bottom is down here, so it sits on the table like this, and the buttons are on the side. But again, from the relaxed position of my hand, you can see that fits the relaxed position of the position my hand goes to when my arm just relaxes. The little things like that, if you're going to spend a lot of time on a computer, like 40 hours a week for an entire working career, little things like that can make a big difference. And obviously, I have some examples for those who come to campus. If you want to try those out one day, they just plug up with USB, see what it's like. Takes a little bit of adjustment, especially on keyboards. Like when I switched to that, I learned that for my entire life I've been using the wrong hand for the B and the 6 key because they're on the complete opposite side of the keyboard, on the opposite side of the little hump on it. But keep things like that. I kept referring to the natural, just relaxed shape that my hand goes to. That's the sort of thing you want to look for. Desk, these big square rectangular things. That's a very unnatural shape. And we force our body into unnatural posturing and stuff. And doing that over time causes little bits of damage that adds up. So, for comparison to construction work, here's somebody that gets okay. The construction worker is much more prone to those little injuries that are going to happen. But by the time we get to the age, the construction worker is going to be in much better shape than a computer person that sat at a desk and used that that square shape of keyboard and a cheap mouse. So little things to keep in mind. Yeah, desks are a terrible thing to do to the human body. Is the basic idea. So just keeping in mind some of the idea of ergonomics. You may have heard of it used a lot in terms of efficiency. Because if the human body is just doing things better, that's you can get more work done. So managers really like it for that reason, or you may have heard it before, but it's better for the human body. It's not going to have those little things that are going to be an issue. So the pictures here. Oh, yeah, the one Wikipedia had some really bad had a picture I used to refer to. Okay, yeah. So like the angle you hold your neck at. That picture's not the best one. You don't want to be looking down at a computer screen the whole time, constantly, right? That 40 hours a week of that for years and years and years is really going to wear on your neck. Well, the search results look like there was pictures there. So you can see there's differences. Standing desks make a big difference for a much more natural posture. And if you got comfortable shoes, it's not bad to sit there. When we're seated, it puts pressure on our spine in a strange way, so we end up with lower back problems from desk. And if you're in this class, you're sort of heading down one of those pathways. So keep things like that in mind. Like those keyboards. Anybody that comes to campus, those are just sitting in my office. If you want to give one a try next time you're on campus. Look up ergonomic keyboards. The price range is wildly, but it's usually about the same as equivalent to other keyboards. They have some that are completely split off, so that if you're in a chair with armrest, you can put each half of the keyboard on a different right on the armrest, and then you can stay in like a laid back position where you don't have that weird pressure of your spine pushing straight down on your hips with nothing underneath it to respond. The thing that wears on our lower backs. All sorts of them. You can see how that really matches the shape of the human hand. But yeah, just the ones that have that little bump in the middle make a big difference. Or split keyboard. I'm gonna do this is actually the best one. So, um, is it orthopedic feet, isn't it? What if the hand doctor is? Hand doctors. So this wasn't designed by engineers just trying to set up a grid on it like the normal keyboard. This is one that hand doctors, maybe that is orthopedics, or orthopedic hand and feet, but medical experts on the human hand sat down with the engineers and came up with this as the optimal design for it. Obviously, you're gonna have to completely relearn how to use that thing, but it you can see the different shape of the keys and going in a circle, and our hands just stay in a very natural position and naturally relaxed position the whole time. I've never tried this. It looks like it'd probably be comfortable to use, but again, have to completely relearn to type. Um, Vertical mouse, that's like the example pulled up. You see it's a very natural, you keep your hand in a natural shape. So you're not constantly holding it in a position your arm doesn't go to on its own. Right? If you hold your hand in the mouse position, like the normal mouse, the way we would hold a normal mouse, just hold your hand in that position, and you can feel that it's pulling your muscles up by your elbow. And over time, that constant little bits of tugging are what wears out the carpal tunnel. And then your hand just always hurts. And they don't give disability for that. So just something to keep in mind. So those analog keyboards, vertical mouse are better. Trackball mouses are pretty nice. Some people like those. Um, Artists tend to like these a lot. That's where the mouse is stationary and you just move the little you move the ball. You roll this wheel around. Um, and the mouse has like rubber feet, so it just stays stationary. It has the nice advantage like drawing on a laptop with the trackpad, where X and Y never move for you, right? Because with a regular mouse, but if you twist that just a little, the X Y direction that's feeding into the computer changes. That can throw you off pretty quick when you're trying to do graphics stuff. So yeah, with the stationary mouse, the X and Y is always the same direction. So artists really like those. Some of them go a little bit slower. You get better control. You can go super slow or super fast with them. I mentioned desk and change. Uh, those are yeah, the big rectangle ones, right? Nothing in nature is just a big rectangle, big flat rectangle. So a really unnatural shape, we have to adapt our bodies to fit into it. So standing desks are better because then we're just standing beside that and we still have that flat surface for our paper and everything. But does anybody know what the best position for the human body to work in is? Probably like a desk or something. Anybody seen that before? Standing is really good. Standing still quick. Standing is much better than sitting at a desk. Uh, the the best position for us is zero gravity. Zero gravity workstation. They put something called zero gravity in cars. This is zero gravity car seats. I don't know what they're talking about because zero gravity position is this. Notice where, if you think about the way gravity is pulling, notice where all of the pressure is going to go on your body. back is just being pulled straight down, so you don't have pressure on the different vertebrae, and your things are directed towards your hip in a more natural position that way. So zero gravity stuff, some of them get quite expensive. I know some at the top they had a bunch of the scorpion ones. Those fold up, so you like sit down in the chair and then you hit a button and all that stuff comes out from behind you. It looks really cool. A lot of money here, right? But if that's something you have for your job, then that's a business expense. So that's something that comes off your taxes. And really expensive stuff is rough when you're a student, but when after you graduate and you're making really good software developer money, right? 150, 160 grand a year. The IRS is going to want a great big huge chunk of that. So having expensive items that you can write off as business expenses make a big difference. They have cheap, but they come in all different price ranges. These are full workstations. They don't have chairs. So sitting there with the laptop, and that is a professional model. I'm sure we would all panic the first time the chair goes to that position. The model, professional model can sit there and smile. But it's, right, it's like your chair, almost like a falling position is what it is. And some of those would be a lot cheaper. You can get set them up to work in, but that's sort of the best position to work in. So having something like that for your desk. They look really cool too. Standing desks are also great because depending on the position, you might need to get out of your desk sometimes. Looks like those are for when you're going to work for hours, right? You sit down at that zero gravity workstation, you're not getting up for a minute. But like was mentioned in the chat, so standing workstation. Desks that go up and down, and then we're just standing beside it, kind of like in a kitchen, working at the kitchen counter or something. A much more neutral position. It's easier to get away from the desk and maybe get steps in and stuff. I'm gonna get into that part. I'm sure everybody's already put all the exercise and stuff. Keep those things in mind. And a good thing to look into ergonomics, or just look into ergonomics, and that's a good starting point on getting research in that. It increases productivity because all the workers' body do better. That's what, so managers really like it. That's probably where you've heard it before. But for anybody in this class, you're here learning the skills you need for a desk job, which means you're probably going to end up in a desk job, sitting at a desk for a full-time working career. And that's kind of a terrible thing to do to a human body. I just like to go over that spiel every time, and I have, like I said, I have some of those ergonomic keyboards, the vertical mouse. So those who do come to campus, next time you're up here, just we can grab one of those out of the office so you can give it a try, see what it's like. A lot more comfortable to work on. Something to keep in mind. Next up, maybe a little bit with stuff with material. Let's start off. I'll share screen, and I'll just go into Godot into the materials. And here in a few minutes, then we'll go over to Blender later. We'll look at some more stuff about materials in Blender later. Yeah, I'll just create a new project. Yeah, probably not going to save this one. We're just going to look at the kind of click through the list and talk about the things on there. And then we'll go over to Blender, and Blender has a bunch of better rendering options, and Godot and Blender are fully integrated. So all you have to do is make sure you tell, if you go to editor settings and somewhere in here, I have to dig through to find the buttons. I can look at it here though. Basically, all you do is make sure that Godot knows where Blender is located at. Probably should have refreshed where that was at on here. Ah, so in the file system, and external programs, you can just point to where Blender is installed on your computer. On a Mac, it's going to be in applications, and on Windows, it should be in programs or programs x86. And on a Linux, it's probably in the Etsy folder. But just point to wherever that software is actually installed, and then they work together. They're fully integrated. We'll get to Blender in a few minutes. I'm just going to create a new node, sort of root node, and just put a mesh instance on it. So mesh instance 3D, and let's just choose a random shape. Torus, good shape. Donut shape thing. So there's all those vertices, edges, and faces build up into that shape. We talked about earlier. We can start manipulating them. A lot of properties about them. But as we come down here, there's one option for material, and this is what we have instead of color. So our options are standard material, overend material. Let's pick on first. When I expand, you see we have all these different options. Has to do with texturing and things. I'm going to clear that out and start with clear that, and then put in a new standard material, and then the shader material we'll look at Wednesday. Shaders when we do it in code, but usually the industry standard is visual scripting. We'll look at the text thing, but yeah, we're somewhat limited on time. Just have a couple small examples. Yeah, we'll put generative clouds in the sky and ripples on water are the normal examples I do. Might do some other stuff with grass or get into height maps, depending on how much time it takes me to take. But you see, we have all these different options to expand the transparency of the object. Can add an alpha channel so that it's somewhat transparent. Adding to the object, taking away from it, expanding things. I'll leave it at mix. Culling is the side we don't see. So if we have back face culling is the normal thing. So the front of the face is here pointing out. If I zoom in a little, if I turn this, we'll see how we're like actually inside of the material here, but we can see through to the other side. So that's back face culling. The back face is not visible. So only the outside of the object is. So checking how to tell which is the front and which is the back face on all of those, every single face on there. Sometimes we'll put our models together, and as they get more detailed on lots of little bitty faces, some of those faces might inadvertently got turned around, so the back if the back face is facing outward, so when the culling happens, uh, we see something different, so. There's front face culling, them, uh, I guess you can kind of see it there. We see the inside of the object instead of the outside of it. Uh, Different things about transparency there. Shading, how is it applied? Are we going? Yeah, really, it's come down nicely. Um, are we just leaving it completely off? Are we applying things to every single pixel on the screen, or to just the vertexes? If we want to use the vertex, color each vertex individually, uh, we kind of set up options there. First one we're usually going to want to go to is albedo. That's the color. So you just choose some color for it to be. I'll choose a random blue color. Textures, we can load in different things. Viewport texture would be kind of like the viewport of our thing. We can have something else going on, right? The viewport's that big section in the middle where we're seeing this scene. So we could load in another scene that runs. So maybe think of like a TV screen in your game. Canvas textures for drawing. Image texture, we load in images, but I usually do that in Blender and bring them in because one thing about this, um, you'll notice that there doesn't seem to be a load button to load in a file. I guess I could try to load in an image. Let's go grab an image like beach image, some random picture. That was a very nice beach. Save. Wait, is it download? So, oh, I accidentally cleared that shader off, so I can go with the new standard material. And instead of a color, I go to albedo, just choose a texture for it, and load in that texture. Oh, I went over here to drag that into the project and completely forgot to do that. There we go. Now that we have a texture there, we can load in that image. And that gives us you can see what it does. Then that's the material it looks like. That's on there, and can make little adjustments. So texture force puts the image over the color, and then the other one, the MSDF, so that's the metallic, the um, metallic specular diffusion, and I can't remember what DF stands for, but that's our normal color things. That's like what we had when we just chose the color there. We go to albedo and just choose some random bluish color. Probably normally set up a color. Then metallic can be how shiny it is. So if we turn that up to 1, something close to 100%. Specular is how much light reflects. So if we turn that down, versus all the way up. We're not doing much yet. Let's try to roughen this down. So right now, it's processed as a really rough surface. So I'll turn roughness all the way down, see how it looks a lot more metallic now. And as we adjust the specular, the change I was expecting to. More like the flex, that's how much, you think of a car would be a good example. So it's a metallic surface, got that paint on it. But if it was recently washed and waxed, it's going to reflect a lot more light than if it's dirty. Right? Then if like after a snowstorm when the roads were just salted and it has that thin film on top of it that blocks out the light. That's sort of what the specular is. And apply a texture. And notice how we don't get our image here. It's kind of breaking it down. We can see bits and pieces of the image. But what it does is it breaks down the RGB values. Red. So we're just looking at the red values there. And then the scale of red for every pixel, right? We have some red, some green, some blue to make up every pixel. So we look at the red ones, and then that adjusts how metallic it is, our metallic level. So some parts of room have real high metallic, some have real low. We can switch that. Look at the one of the other channels. Or just grab the grayscale from the image. And then instead of moving the slider here, looks like the red does the most. The red controls how that how much that focus. I'll go back to just the slider. Roughness again is it a smooth or rough surface? How polished is it? And once again, we can just load in an image and use either the red, green, or blue channel from that image to determine how much in place of the slider. So anything that has the full blue value, right? 100% on the blue becomes 100% on the slider. Something that's all red and green, right? 100% red, 50% green, 0% blue, it's going to become 0% on there. So we get a lot more depth to how that applies. I'll go back to metallic when, or maybe a little, turn that up a little. Emission is putting off light along with the light that reflects off of it. Does it sort of have its own light source? So if we choose a color here, because we no longer have shading on the bottom, it's putting up its own. How bright is it? Turn it or you can change how it applies. Let me check this. So notice right now, since it's metallic and not very specular, that shadow on the bottom, the light is above us. So the bottom of that doesn't get any light whatsoever. If it starts putting off its own light, even a little bit, it cuts down on that shadow some. And the brighter this gets, oh, that. The brighter it gets, the more it's going to do stuff. Obviously, when this is 0, we're not seeing anything. I'll keep that on that. Multiply is starting to get into linear algebra to explain the difference on those, but the values apply differently. Uh, on UV, I'm not going to see anything on that one, but this is the first place UV has shown up. So UV is just our coordinate axis. So think about that texture. We loaded the texture in. Um, it's a flat surface, so it has XY coordinates, and the XY coordinates in that picture are different than the XY coordinates of our world here, or the XY coordinates of every individual polygon face making up that object are different than the XY coordinates of our world. So anytime you see UV, that's just referring to the individual objects. I shouldn't say object, the individual item what you're looking at in that case, whether it's a some sort of texture image, a 3D model like this, or each individual face in the 3D model. That UV refers to their XY coordinates, just as the next couple letters in the alphabet. Normal math, a normal, that refers to the normal direction. So a normal direction is the one that comes straight out. So like from the board here, from any flat surface, there's going to be a direction that points straight out. So when we have lots and lots of flat surfaces like we do on the torus here that eventually make up all of that, make up that nice smooth looking surface, there is a straight out direction from every one of those polygon faces. And it's slightly different, that's why it looks curved, but we can manipulate that. And that's what we'll do on Wednesday when we work shaders. We'll manipulate it dynamically. So like for to make it look like ripples on the water, we'll just have a perfectly flat plane, but we'll tell it that we'll add in a normal amount so the computer won't think it's perfectly normal. Get into noise that day as well. So I'll load this in. Notice how it doesn't really look quite so flat anymore. We're using the image data from this. I don't see a place to change it, so I'm not sure which channel it is. But the different colors in that map or that image now define what the straight out direction is. So as we turn around, it doesn't look quite so flat. It is still flat, right? As far as processing, it's still perfectly flat. It's just the light reflects off of it in different directions, making it look like we have different little dents and things in there. So we'll do something like that and then make that move with time to simulate ripples in water on Wednesday. I'm just going to turn it off now. We're talking about what some of them are. And you'll want to go through and just check these things out. What is try different things, see what happens when you change values. Look, turn way up. There it is. The rim lighting effect. So I guess we're probably not seeing much of that because we have a smooth surface, not there's not any edges like the rim glass. So it would be like just inside the room. Things look a little bit different. How the shadows apply and things like that. Clear coat, we can just enable that and turn down the smoothness. Turn up what that means. since it was pretty really metallic and shiny when it's in mud. But if we had a really rough surface and put a clear coat on top of it, right? Just like think about paints. If we have a roof that's like wall and we paint it, it's still a rough surface and looks like a certain way. But if we come back uh, with some sort of clear coat smooth that smooths everything down, it's going to look very different than if it was still a rough surface. But we had a shiny surface, so clear coat's not doing much of this. We want to kind of come through here and check out what the different things are. Turn them on, see what it does. See as I turn this all the way up, the little glare we were getting turned into an even ring everywhere. So that's like, how does the glare distribute? And see, we can also load a texture in there for that and get uh, much more interesting looking materials than just solid colors. So go through and try a few things. Um, it things come together really nicely. Height. This is if we use like say a normal map. Let me load that image in. Turn this on. I'm not seeing. Okay. This is so a normal map. We saw just that changes what the straight out direction is. Oh, okay. It's going to change what our straight out direction is so the thing looks a little beat up. And then the height map, when we apply a normal map, uh, a texture, some sort of texture to it, it does actually raise and lower it a little bit, sort of displacement stuff. Um, Ambient inclusion, turn this on. This one really needs to go with the texture, and we'll talk about noise texture. That's what we probably use more on Wednesday. Uh, what sort of effect is it giving us? Some of them are very subtle, some of them much more pronounced. But as we combine all these things, we get better and better looking objects. Uh, you can kind of see what they are there. Just kind of go through and play around with them. Is my first suggestion on that. See what each one does, build it up. Sure, I'll save that. Close out. I'm jump over to Blender real quick because I'm much more used to doing that in Blender than in Godot. Those options are there. I'll just do a real quick example so we can see some of the what a different, how much of a difference it makes. So first off, I'll select everything, delete that, and I'll just do a really quick example of like an axe, making a small axe that we can use. Has anybody looked at the assigned learning materials this week? Take a moment to do that. So there is a modeling assignment this week. It involves, it leads into your next game. The next individual project is a proper simulation. That's why we talk about physics. We talk about physics so we can apply physics simulation. It's going to be a pool game. Um, so you're going to need to create the models for each one of these, which some of them are going to be easier than others, right? Like the pool balls, those are just spheres. So all you have to do there is set the right size, add some coloring to them. But on the learning materials page this week, um, this document has all the official dimensions, the sizes, and the masses of all the things for pool, which taking a long time to load. It's just a text file, but you'll need that list for when you go to code it up. Okay. That's taking a long time to load. And then there's 3 videos in here. You can see about all 3 of them are less than 20 minutes, but it goes step by step through building the pieces we'll need for the pool game. Well, the video only does one pool ball, but obviously the other 15 pool balls are exactly the same as the one. They would just be a different color. I put a message on the screen, but at one point I meant to type 20 millimeters and type 40 centimeters for like the little tip at the end of the pool cue. Um, Everything else in the video I'm happy with, so I didn't want to make the whole video for that. So I just put it out to the screen that uh, 20 millimeters is 0.02 instead of 0.2. Uh, but accurate, so, and then table. So step by step videos, how we do that, get a little bit of practice modeling that way. Um, I'm just gonna kind of go through here, make a little super fancy one. So I'll start with a cube. And the cube is the unit cube, so it starts at the origin and goes 1 unit in each direction, which means that each side is 2 units long. I think it's set for meters right now. So the first thing I always like to do is scale that down by 50%. So now it's a 1 meter by 1 meter by 1 meter cube. And then if we hit Control A, we can lock in those transforms so that 1 meter becomes the new 100%. And then especially with meters, so if we wanted something like an hex, it's going to be what, an inch thick? That's 0.0254, 2.54 centimeters. So once we get it to meter, we can just kind of set it up that way. A foot is somewhere around 30 centimeters, and a little less. The axe blade probably wouldn't be a foot long, so maybe something like 18, 0.18, 18 centimeters long and 0.035 tall. What's that scale look like? Be a little bit long, so 0.0. Let's see if there's 2.5 centimeters per inch. That'd be 5 centimeters for each for 2 inches. And if that should be about 8 inches long, 5 times 4 would be 20. Yeah. So that's about the size I was looking for. Then, and there's Z is at 0. That's why. 0.23. Make it kind of big at first. There we go. So make that look like an X. You go in edit mode and um, I'm gonna switch to wireframe so that I can just draw boxes. If we have a wireframe, we can select the vertices behind the one we're looking at too. So select the front and back there, and then if I hit which direction am I looking at? All right, so now I'm looking at the positive, down the positive Y. So I'll select like the back of the X and scale that down to Z. Make that really small. Let me try that again. Scale S to scale, and then Z so that it can only scale on the Z axis. Something like that. So I'll go from here and push Control R, and that like cuts rings in it. So I'll click twice to put a ring right in the center. And then if we select the two vertices, hold Shift for multiple selection, select those two vertices and move that out, that'll kind of look like the cutting up to the X. I'm gonna do S and Z and scale that down so it's like the so yeah, a very quick accent. This. Um, then the X is gonna need a handle, so I'll add it in a cylinder. Which again, it has a 1 meter radius. So if we cut everything by 50%, now it has now it has a 1 meter diameter. So that if we wanted to say, think about an X handle and it's going to be about 2 inches across, which would be 5 centimeters, we can go right to it as soon as we hit Control A and set that 50% to be our new 100%. Kind of reset those transform down. Because then in our X and a Y, we can say 0.05, so 5 centimeters, which is about 2 inches, and 0.74, 2 foot long handle. And you just grab this and move this up. Something like that. Maybe it should have been a little bit longer. Not the best axe I've ever drawn, but a quick example, because what I want to look at is the materials. Oops. I'm going to save this. That's when I was getting ready. So I'm going to make a new folder because remember, just like we saw with image textures a moment ago, we're going to use an image texture to make that look a lot nicer. Oops. I'm going to make a folder called Axe and then save it in there. And well, we can look at it quickly before down here at the bottom. This thing looks like a beach ball. That's our materials tab. And then up here at the top left of the viewport, these buttons change how we're viewing it, whether it's wireframe or just the solid shape or view our materials. And then we saw before we can choose materials for it. So like for an axe, we'll create a new material, which depending on how big your computer is, sometimes you have to be patient. I can't remember if I said so or not. I always make it a point to teach off one of the cheapest laptops at Walmart. Since this is a community college, I assume there's quite a few people that all that's in their budget. So if something doesn't work on the cheapest computer at Walmart, I change the assignment. So for steel, maybe a little bit of a bluish tint. Um, Turn the metallic all the way up. The roughness all the way down. And see how it's reflecting in the background. And we'll see if the background is reflecting in just a second. So nice, smooth, polished thing. Then we get a little bit of roughness in it. There we go. And now it's not quite like a perfect mirror. The background is reflecting is this right over here. We're gonna go. It's a blurry scenes out in the park. On a handle, probably a wooden handle. We probably want some brown, something brownish, and turn the roughness way up on that one. Maybe a little darker, something like that. And we talked before where we can get a little bit of control over that, but we can make that look a lot better. The next step is we need some sort of texture to that surface. So I'm going to the shading pad. Here you can see the background that's around it. I'm gonna zoom in. Oh, apparently I was upside down. I didn't realize that. Oh, yep. There's positive Z. So that's really symmetrical. So I think what I meant to do was have Z up and then put this near the top. Didn't even realize I was upside down there for a second. Now, as soon as zoom buttons go away, I'll go back to the shading tab. There we go. So we zoom in on it a little, and then most of the work we'll be doing down here. So right now we have these. These are our nodes. This is the low-code scripting sorting nodes that most modeling, graphics software, and game engines kind of work with. So right now we just have two, right? We have that principal shader that has a base color, metallic, roughness. I'm gonna turn that up a little. You can try different things like we were doing a moment ago, but we can do better than a color. So let's go grab an image. And just to break it up a little, I'm gonna go to concrete images and see if there's a good texture here. Something like this. So notice how we have a bunch of different grayscale there, different textures. I'll try this. I'm gonna grab this some concrete image. Notice how it's not very even. So save this image. Might have to come back and get another one because there's not much grayscale there, right? There's light gray and light gray. I don't really have much dark there, so we might have to come back and grab another one, but I'll try this. This is what I usually grab a concrete image for metal, and I'll go with the wood grain image. There are others we could use. Find something that looks like a wood grain. That looks good. Save image. In that same folder as the project. I'll leave that browser open because we might need to change that concrete image. But notice we can have an add button up here. We can add more in lots of different nodes. You can kind of see you can look through the list and see what's there. There's lots of them we can do. Start with texture. That's going to be your images, right? There's already some default textures in there, bricks and checkers, different environments. Noise we'll talk about soon. Image texture. We have an image, so I'm gonna drag this over here and drop it somewhere. Actually, keep things neat. I'll put it right underneath this one. And load in that concrete image. And I don't want the colors for that. What I want to use is a displacement on that so that we actually end up with a rough surface. So if we add go to add, and under vector, there's displacement. So along with that color feeding into our input output, maybe turn down the metallic a little, some adjustments. And it's like the mirror from finish. A highly polished metal, that still doesn't look very realistic because it's just so smooth and flat. So if we take the color from that image and feed that into a normal net, just talk about a normal, we're going to take every RGB value in that from the grayscale of that image and assign each one of them a different level of height. And coming out of that, we get a displacement, which we can connect to the displacement of our output. And as we adjust this, as we turn it up and down, we should be getting yeah, that color. That's what bring that image. We're not getting it from that. So let me reset that 0, 0, scale of 1, and try different image. I'm going with sand. Looking for something that has a lot of texture to it. So this one, notice how we have lots of light and dark spots and quite a bit of contrast between them. Similar thing on this, we have lots and lots of uh, little grains of pan with a lot of contrast between them. I'll go with this one here. Let's see what this looks like. If I save that image in the same place. What? That. Okay, so this one I come in the color. And notice we have a stark contrast. That the reason that concrete didn't work like I was hoping it would is the there wasn't enough contrast. But here we have a little contrast between our light and dark areas. So that's really that. So I'll push it, open that sand file. And now with this, notice how it gives that a lot more texture to it. The height, and um, it is actually kind of displaced, and it's no longer a smooth surface in there. So turn up the mid level a little, adjust the scale it up or down. How much is it affecting it? With what I just have there, if I switch to blonde, it start to look like a rusty axe, or maybe something copper with that one I just picked there. But see how we get all that different, get the actual rough tones from using an image texture into a displacement model. So that's one of the first things to do to really improve the materials, make your game look a lot better. I'm going to come over here and add in the same thing. So a texture, an image texture. This time I'm going to do it different. I'm going to take the color and feed that into the color of our material. Oh, I forgot to load in the wood picture. All right, load in the wood picture. There we go. And now notice that it's just that's just directly what colored it. Not a lot of colors on that. We can change the way it lays. So like you can see the different options there. Try different ones. Set it to repeat a repeating thing. And set it up dynamically like gives plain. So I'm gonna do that for the color and add a displacement vector. Sometimes these are called spaghetti code things. There's something no the strings. We just grab the output of one. So the outputs are always on the left hand side. And or sorry, outputs are always on the right hand side and inputs are always on the left hand side. And connect all these things together. We have similar editors in all of our game engines for materials, and Godot just removed theirs for actually writing scripts, but when they get to Godot 5, they've got a nicer one that they're going to put back in. They just took it out because it's not backward compatible with the one they used to have. Feed that into the displacement. So now that image controls the color, and and kind of adjust that height and mid-level to get so the grain of the wood is actually what controls it. So that's sort of the next step in materials, adding in image textures and using those as normal maps to set up displacements, or we'll see on Wednesday when we go over shaders how we normal maps just for light reflection or displacement, which in Godot that was that option that called height. It sort of displaces, gives us little bits of displacement based off that normal map. And you can see that we very quickly get to something that's a lot more realistic looking. So something to play around with. Yeah, it takes a little bit of practice, try different images. I've had a lot of good luck in the past with concrete images, but when I Googled concrete images, all of them were like very, very close together. Maybe I should look for aggregate concrete, the ones where rocks still show, and then they're like, there's a lot more color gradients in it. Maybe something like that that I'll draw. Right. But it doesn't have to be like the wood image on that wood handle. Right? We use an image of sand to get that the surface looking like cast iron, I guess. Looks like something cast in this case. Cast in a sand mold, so like a bronze. That's not the best one I've ever done, but we're looking at the materials here. And as we look at different angles to see how it did displace that just a little. One more I want to look at, one more of those I'm going to look at after the break, where we can manipulate with that on a much bigger scale instead of like just an image texture to make it all rough, but manipulate them all on a larger scale. So we'll take a quick look at that after a break. We've been at it for over an hour, so probably a good time for a break. 10 minutes sound good to everybody. And we could certainly use a cup of coffee. So my laptop says 2:15, so we'll get back to it at 2:25. I'm gonna go grab a cup of coffee. See y'all in just a moment.